Okay, so question number 8 says that proof by contradiction P is true, right? And I went to tutoring for this, but I don't know if I fully understood it, but here's what I got, right? So what Brandon said, the question basically says, all of this is true, right? So you could say that this is your hypothesis. Cool, cool. And then your conclusion should be the fact that P is true, right? Right? Let me check. Uh, yeah, okay. So the way we start if it's a proof by contradiction is to not do a double flip but do a single flip. You have to negate the thing you're proving. So what we're trying to prove is that P is true, right? So if we do a negation, that's going to be P is false. And in CS, we learned that true you can say is 1, false you can say is 0, right? Okay. So, now what do we do? Okay, so P, pretty sure that's a OR. P or Q implies R, right? And then you have Q or R, and then you have R implies P, right? All of these statements are true. We already know the value for P. The value for P should be 1, but since we're proving a contradiction, we're going to go with 0, right? So 0 or Q implies R, right? I drew the truth table here because this gives you the value for the things, right? So the prompt says if P is true, which it is, this thing should be true, right? But we don't know that yet. And we cannot find that out because we don't know what Q is or R is. So that's why we go to another thing that he gave us. So we just basically put a star here, put a pin in it, and then we will come back to it later, right? So Q or R is true. In OR, only one of them need to be true for the whole thing to be true, right? The truth can be either from Q or from R. So that doesn't really help us because we don't really know what it is, right? So we're gonna put a pin in that as well. We're gonna come back to it. This one we do have a value to put in. We can say R implies 0. Now, this thing is true because the prompt tells us that that statement is true. R implies P is true. Now, in what value of R implying 0 is a true statement? So if we go back to the truth table here, R implies 0. So that's going to be this column and this column, right? And it's true, and true is 1. So that's not going to be this, that's going to be this. That's the only one that's true. And if you look at that, both of the values have to be 0. So not only is P 0, R also has to be 0, because 0 means false. And 0 implies 0 is true. So far we know R is 0, we know P is 0. Cool? Cool. Now we can put that into here, because now we know what R is, right? So we can remove the pin from there, and now we can go back. So we know the value of R. The value of R is Q or 0, right? Now, we know that this is a true statement, but R is 0, so R is false. In an OR thing, at least one of them have to be true for the whole thing to be true, right? So that must mean that Q is true, which is 1. So this thing is true, right? Now we know the value for Q as well. So Q is 1, R is 0, and P is 0. P is 1, but we're trying to prove that's 0, right? So far, everything we made is just all logical, right? Now that we have all three values, we're going to plug them in back into the original big thing, right? We're going to remove the pin and now sub it in. So it's going to be 0 or Q is 1. We figured that out. And then R is 0. We figured that out, right? Now, this thing is supposed to be true. Cool. So now we're just going to see if it's true or not. Our objective is for it to be false so that by contradiction, P would be true. Well, we don't know yet, right? Let's see. 0 or 1. 0 or 1 is 1. We get that from the OR table, right? And then R is there's nothing there. So 1 implies 0. Now, is this true? Is 1 implies 0 true? No, it's not. The only time the OR table is false is if the... Oh, wait, how do I explain this? One implies 0. Oh, I know. So, look at the truth table. Look back here, right? This thing. P implies Q, right? So let's say P is 1. Let's say Q is 0. 1 implies 0. If you go back here, 1 implies 0. That's false. So, this thing right here, this is false. But the prompt said it's true. The prompt didn't say that 1 implies 0 is true. The prompt instead said that P or Q implies R is true. But if you plug in these values where Q is equal to 1, R is equal to 0, P is equal to 0 onto here, this thing is no longer true. This thing is now false. Since these values don't work, there has to be a flaw. And the only flaw we made, because we just followed logical steps, right? We started off here, we figured that out, we found the values for R and P. Then we came here, we figured that out, and then we subbed in here, and then we figured this out. We got 1 implies 0, which is false. But the prompt says it's true. So the only logical mistake would, whoa, it's horrible handwriting, would be that the starting point is flawed. And if you remember, it was flawed because we said P is false. If P was true, then it would be true. If we said it's 1 or 1 implies 0, wait. Yeah, if it was here, then R would have a different value, Q would have a different value because everything was here. The first step we got was to determine the value of R, which is dependent on P. So if P changed, then all of this would change, and this thing would be true. Since we messed up P, that means P was the mistake. P is flawed. It's not false, but rather true, as proven by contradiction. There you go. So we continue to make logical steps, and after we find out something that doesn't satisfy the original condition, we go back to the beginning and we say, the reason this doesn't work is because we set P to be something that it is clearly not.